Our next lesson is solving exponential equations. We are going to be talking about solving exponential equations later on as well. That will be using something called logarithms. This is just using the exponent rules that we've been talking about previously. So there are 4 steps to solving an exponential equation. So the first step is to find a common base. The second is to simplify the exponents. The third is to equate the exponents or set them equal to each other. And the fourth is to solve for the unknown variable. Now, I completely understand that those steps probably don't make any sense to you right now, but they will as soon as we start doing the examples. So I'm going to go through just one question with you right now. If we have 4 to the power of x plus 1 is equal to 2 to the power of x minus 1, and I asked you to find x, these are the 4 steps that you would take in order to solve this. So step number 1 says find a common base. Our base has to be at least the lowest number. So since our lowest number is 2, we're going to see if we can change this 4 to be of base 2. We know that we can do that because we know that 4 can be rewritten as 2 squared. So what I'm going to do is I'm going to rewrite the 4 as 2 squared, but I'm going to leave everything else the exact same. So my exponent of x plus 1 stays, and the entire right side stays the exact same. The only thing I've changed is that this 4 has now become a 2 to the power of 2. Step number 2 says simplify the exponents. We know that on this left-hand side, we have a power of a power. I have a power of 2 to the power of x plus 1. So we know that this has to be multiplied through. So this can become 2 to the 2x plus 2. The 2 gets multiplied in with the x and with the plus 1. Now that's going to be equal to 2 to the power of x minus 1. Step number 3 says equate the exponents. If I have my bases the exact same, then it only makes sense that whatever I have for my exponents must also equal the exact same. So I'm going to have 2x plus 2 is equal to x minus 1. I get to basically ignore my bases and I get to move the exponents down and just solve this way. Step number 4, solve for the unknown variable. So what I'm going to be doing here is I'm going to be moving all of my x terms to one side and all of my numbers to the other. So 2x, this x will become a negative x when I move it over. I'll keep my negative 1 here, and when this 2 comes over, it's going to become a minus 2. 2x minus x, or minus a 1x, is 1x. And negative 1 subtract 2 is negative 3. So what I've just solved is that x is equal to negative 3. Now obviously I could go back and I could plug in my x here and just check on a calculator to see if it makes sense. And you can do that if you feel like maybe your answer isn't correct, or even if you just wanted to double check your work. The only way for us to get really good at these questions is to go through a lot of examples. So I'm going to go through 7 examples for you today. When I take a look at this first one, the first thing that I'm noticing that's different is that on the left-hand side I have 2 terms instead of the 1 that I had in my last example. So the first thing that I need to do is change that. When I look at this, I do see that we have some things in common. So I see a 3 to the x plus 2 here and a 3 to the x here. Now, what I can decide to do from that is I need to factor something out, okay? All of this comes with practice, so if you don't see to factor something out right away, don't panic. When we do more and more of these, this will become second nature for you. So right away, I know that I can rewrite 3x plus 2 as 3 to the x times 3 to the 2. Now this is kind of backwards thinking, because before what we would do is I would give you this kind of question and I would say simplify it. So now you're basically unsimplifying things in order to do this question. Now that I've split apart the 3x plus 2, I can go ahead and I can factor out my 3 to the x. So when I do that, from this first term, I am just left with 3 squared, and from the second term, I'm left with a minus 1. I know 3 squared minus 1, so I'm going to go ahead and I'm going to do 9 minus 1. 3 squared is 9, and then I'm going to go ahead and I'm going to say that 9 minus 1 is 8. At this point, it's probably a little more obvious what we're going to do in order to solve this question. So my goal is to get x by itself. I'm going to divide both sides by 8, and I'm going to be left with a 3x on the left, and 216 divided by 8 is 27. At this point, this is where I'm going to start following the 4 rules that I set out on the last slide. So I need to get my bases the same. I can change 27 to be a 3 to the power of 3. Now that my bases are the same and they're simplified, I'm going to go ahead and I'm just going to equate my exponents. And I don't even have to solve. All I'm left with is that x is equal to 3. Example 2 will be a little bit easier for some of you. When I look at these numbers, I only have one term on the left, one term on the right. I see a base of 5. I see a 1 over 125. I'm immediately recognizing that I can convert that 1 over 125 to a base 5. I know that 5 to the power of 3 is 125. All I'm left with dealing with now is the 1 over 125. But if I think back to my power laws or my exponent rules, I know that 1 over something means that I'm having a negative exponent. So I know that 5 to the negative 3 will give me the 1 over 125 like I need. When I look at this, I have the same base, so I can go ahead and I can equate my exponents. So 2x plus 1 is equal to negative 3. I'm going to move the plus 1 onto the right-hand side, and I'm going to get 2x equals negative 3 minus 1. So 2x is equal to negative 4. I'm going to divide both sides by 2, and I'm going to be left with x equals negative 2. Example 3 looks the craziest so far, but when you really take a look at it, if I told you that somehow in here there was going to be a trinomial that I wanted you to factor, maybe you'd be able to recognize what's going on. So basically, I'm going to do a little side note here. If I let x equal 2 to the x, maybe I'll choose a different value here. If I let y equal 2 to the x, then what I could do is I could replace these terms. So y squared would be 2 to the 2x, and I'm going to do another side note here. If I had 2 to the x times 2 to the x, it would be 2 to the x plus x, which would give me a 2x. So that's why it's a y squared. Minus 7, I have a 2x here, so that would be a y minus 8 equals 0. So right away, I can convert this into this, and hopefully at this step, you'd be able to see that you could easily use trinomial factoring or simple trinomial factoring to factor this out, and you would be getting y minus 8, y plus 1. Now, if that wasn't obvious to you, you had to find two numbers that multiply to 8 and add to negative 7, so a negative 8 and a plus 1. At this point in time, I'm going to go ahead and I'm going to replace my y back, so a 2 to the x minus 8 and a 2 to the x plus 1. Now, just like solving, we know that in order for this entire equation to be 0, we could have two things happening. We could have our first bracket equaling 0, or we could have our second bracket equaling 0. I'm going to go ahead and I'm going to solve these both separately. So I'm going to have a 2 to the x equals a positive 8. So I took this minus 8 and I moved it to the right-hand side. Now I know that 8 can be rewritten as 2 to the 3, which means that I can go ahead and equate my exponents and get x equals 3. Now for this one, I'm going to get 2 to the x equals negative 1. Now there's no way that I can ever get a negative 1. If it were a positive 1, I could say 2 to the 0, but since there's no way to ever plug anything in for x to get a negative answer, there's no solutions here. So the only answer I'm getting is x equals 3. In example 4, we've got a lot going on. So before I even do anything, I need to take a look at what bases I'm dealing with. In this question, I'm dealing with a 3, a 9, a 27, and an 81. I recognize that I can make all of these a base 3. So what I'm going to do is I'm going to go ahead and I am going to rewrite 3 to the x. I'm going to change my 9 here to a 3 squared, but I still need to keep my original exponent. I'm going to throw that in brackets. I'm going to change this 27 to a 3 to the power of 3. Sorry, that's not very clear. But I still need to keep my x minus 2. And then I'm going to change my 81 to a 3 to the power of 4, but I still need to keep my x. On the next line, what I'm going to be doing is I'm going to be simplifying all of my exponents. So I have a 3 to the x. This 2 needs to get multiplied through, so I'll have a 3 to the 2x plus 2. This 3 needs to get multiplied through, so I'll have a 3 to the 3x minus 6. And then this 4 and this x need to be multiplied together to get a 3 to the 4x. Now that I have all of my bases the exact same and I'm just multiplying these 3 terms, I know that I can go ahead and add all of my exponents. So 3 to the power of x plus 2x plus 2 plus 3x minus 6 is equal to 3 to the 4x. I can go ahead and I can simplify this a little bit. So I have an x and a 2x, so that's a 3x, plus another 3x, so that's a 6x. And then I have a plus 2 and a minus 6, which is going to give me the minus 4. My bases are the exact same, so I'm going to go ahead and I'm going to equate my exponents. So 6x minus 4 is equal to 4x. I'm going to bring this 6x over onto the right-hand side, and I'm going to get negative 4 is equal to 4x minus 6x. So a negative 4 is equal to a negative 2x. Divide both sides by negative 2, and I'm going to get 2 is equal to